Hello, General Biology. We are filming another video. This is about experimental design. So we've talked a little bit about different scientific tests. We're going to focus today on experiments because experiments are a very powerful test. There's a reason why they're the most famous, is that they allow scientists to control what new observations they get so that they can help them test specific inferences or improve specific ideas. So let's get right to it. I have an example of an experiment here. And one thing about an experiment is that a lot of people think that it's a test, but actually an experiment is always a collection of tests. You are always doing at least 2 tests when you do an experiment. So let's take a look at what these tests are. I've actually mentioned this test in an earlier video. This is Louis Pasteur's test about spontaneous generation. So let me describe what was going on. He set up 3 tests, because remember, an experiment is always a collection of more than one test. And in one of the tests, or in all of the tests, he put broth in a flask. And this is called a swan neck flask. And it's named that way because it's got this long, thin neck that comes out of the bottle. So we have broth. And broth is a type of it's kind of like liquid food. And so it's kind of something that bacteria and organisms can eat and get nutrients from it. And so they boiled the broth, and they did that to all 3 of the flasks because they wanted to heat up the broth and kill anything that might already be in it. So right now, there's nothing growing, there's no life, they've killed everything in it, it's just broth. And then they let the flasks sit. But they have done 3 different things, a different thing for each test. In this one, they don't do anything to the flask. This is sort of the normal situation. They just see what happens. They don't do anything. In this one, they remove the neck of the flask. So they've made a change here. And in this one, they don't let the flask sit, but they tilt it so some of the broth is seeping out a little bit. And then they let it rest that way, or they let that broth be all the way down into the neck. So what happens? Well, in the first flask that they let sit, there was no bacteria. In the second flask where they removed the neck, bacteria did grow. And in the flask that they had tilted it all the way through, so there was broth all the way through the neck, when they tilted it back, it did grow bacteria. So what is this? What are their conclusions? What's going on? Well, before we can come to that, let's break down what we saw here. First of all, they were asking a question when they set up these flasks. They were asking, what is the relationship between the broth and the air and bacteria growth? Is there a relationship between those things? And they set up this experiment to see if there was. In every experiment, there is an independent variable. The independent variable is a factor that might be involved in the question that the scientist changes in each test. So we've got multiple tests. In this one, we have the swan neck flask. We didn't make a change. We just used the swan neck. So it is open to the air, but it's open to the air with this strange shape that kind of makes the hair have harder access for things to get into the bottle. In this, they removed the neck. So now this is just straight up open to the air. Anything could fall in. And in this one, they still had the neck, but they kind of coated the neck with broth all the way to the bottom. So if there was anything in the neck could get in the broth and it would go back in. So that was the independent variable. It is how is air getting into the broth. The dependent variable is the thing being observed or studied by the scientist. In this case, what did they look for at the end of the test? Well, they were checking for bacteria growth. Here they found no bacteria growth. Here they did find bacteria growth, and here they also found bacteria growth. That's what they were looking for. So we have 2 factors. We have the shape of the bottle and what happens to the bottle versus the bacteria growth. Those are our 2 factors. The dependent variable, the one they're observing, is the bacteria growth. They also have a control test. A control test is a scientific test that's part of an experiment where you change very little about the setup. So they had the original flask, they heated it up just like they did the others, and then they let it sit. They didn't do anything to it, and they got their results. What happens when you don't do anything to it? And finally, there are variables held constant in an experiment. These are the parts of the experiment that are the same for all of the tests. So they used the same type of flask for all the tests. It was made out of the same type of glass for all of the tests. They used the same type of broth for all of the tests. They used the same type of heat for all of the tests. When you are doing an experiment, the more variables you hold constant, the better. Now, this video is getting pretty long, so I'm going to come back and do the review in the next video. I hope this helps. Struggle well. Actually, I decided that before popping over to the review, we will finish, what does this mean? Well, he inferred that there must be little tiny things that cause life to grow in the bacteria, but the little tiny things have to get to the broth. So when we have just the regular flask, the little tiny things that can cause life get stuck right here, so they never get to the broth, so no broth grows. Here, because the bottle, they just fall right in, and they'll grow in the broth. And here, because they got stuck here, when you tilted the bottle over, it carried them back down into the broth, and they did grow broth. I just wanted to explain that. We'll do a review in the next video. Struggle well.